Good evening, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on differentiating sine and cos, and in this video I'm just going to explain what you get when you differentiate sine, what you get when you differentiate cos, a little bit of an explanation of why, and then I'm going to go through some examples. So first of all, I want you to consider, what is differentiation actually doing? What is the point of it? Well, the purpose of differentiation is to find the gradient function. So when we think about starting with y equals sine x and finding dy dx, what we're really asking is, what is the gradient function of sine x? So I've drawn the graph here of y equals sine x just between 0 and pi, because for calculus with trigonometry you have to be in radians mode, so I've done it in radians. And what I'm just going to consider is what the gradient function of this curve is for these values of x between 0 and pi. And the first thing that I would be interested in is the turning point here, where if I were to draw a tangent to the curve, the gradient of that tangent would be 0. So that means, I'm going to do this in blue, the gradient of sine at pi over 2 is 0. And what's happening up to 0? Okay, well, if I were to draw a tangent in here, at the point where x equals 0, the gradient of that tangent is 1. So I'm going to plot that point up there, because the gradient of the tangent at 0 is 1. Now, what's happening between x is 0 and x is pi over 2? Well, if I imagine drawing a tangent and then moving that tangent along the sine curve, you can see how the gradient is positive, but it's getting smaller until it gets to 0. So I'll do that one more time. We have a positive gradient, and that gradient is decreasing until it gets to 0. So what's actually happening here is the value of the gradient is getting smaller as we get to 0. What's happening past 0? Well, after 0, the gradient of the tangent, if you look at my ruler, it's starting to slope downwards, so the gradient is negative. So what's actually happening now, from 0, the turning point, the gradient is getting steeper and steeper negatively, so further and further into the negative numbers. And what actually happens is, by the time we get to pi, we get to a gradient value of -1. And what you can probably see is this curve here is cos x. So sine x differentiates to cos x. Okay, well, what does cos x differentiate to? Well, handily, I've now got the graph of cos x drawn on, so let's have a look. So you can see I've got a turning point here where x is 0. So the gradient of cos at this point is going to be 0. And then I've got another turning point here where x is pi, which means the gradient of cos at that point is 0 as well. But what happens in between those two values? Well, if I start here where my gradient is 0, I have a negative gradient. It's getting steeper and steeper and steeper into the negatives. And then what happens when I get to this point here? Well, the gradient is still negative. It's getting less negative. It's getting shallower. So what's happening is, the gradient is at its most negative when x is pi over 2. It looks like this. And its most negative is actually at -1. So before that, we're going from 0 and gradually getting more and more negative until we get to 1. So we're doing this. And then after we get to -1, the gradient is getting less negative until it approaches 0. So it's doing this. And if you note the relationship between the original black graph that I drew, sine x, and this red graph here, you can see that it's a reflection in the x-axis, which means that when you differentiate cos, you get negative sine x. And how I encourage students to remember this is sine differentiates to cos, cos differentiates to negative sine, and negative sine then differentiates to negative cos. Negative cos, if you differentiate that, would go to positive sine, and then this pattern of 4 would repeat. So cos, negative sine, negative cos. So when you're differentiating, you'd be working down this list, sine to cos to negative sine to negative cos. If you were integrating, which we're not going to worry about at the moment, but if you were integrating, you'd be going up. So how do I then apply this for different functions involving sine and cos? Well, this first one here, I have sine of 8x. So I just need to think about what happens with that 8. So first of all then, dy by dx. If you start with sine x, you're going to get cos x. So I'm going to get cos of 8x. That bit's not going to, the 8x bit isn't going to change. But because it's 8x, I'm going to multiply by 8. And that's because of the chain rule that we've covered in previous lessons. So I've multiplied by the differentiated bracket. So my expression for dy dx for sine of 8x is 8 cos 8x. Let's apply that same one to the second one here. I'm starting with y equals cos of x over 3. You may wish, if it helps you, to think of that as being 1/3 of x. So when you differentiate cos, you get negative sine. So we've got negative sine of x over 3. But using the chain rule, we'd be multiplying by the differentiated bracket, which is 1/3, which may make more sense to you if you think of it as being 1/3 x. That means that dy dx for cos of x over 3 is minus 1/3, negative 1/3, sine for x over 3. Number 3, very similar to number 1 really, we've just got negative 5 in front of it. So dy by dx, that negative 5 is going to stay as it was. Sine differentiates to cos. It's still 3x, I'll put a bracket around that. But because it's 3x, I multiply by 3 because that's the differentiated bracket. So what that gives me here, negative 5 times by 3, I have negative 15 cos of 3x as my expression for dy dx there. Finally, this one here is a little bit different. I've got sine, and in the bracket I've got x to the power of 6. Not an awful lot different about this. Sine, as we know, differentiates to cos. So for dy dx I'm going to get cos, and then x to the 6 inside the bracket isn't going to change. But because of the chain rule, I have to multiply by the differentiated bracket, which is 6x to the power of 5. So my expression for dy dx would be 6x to the power of 5 cos of x to the power of 6. So there we go. There's your list for how to differentiate sine and cos. Make sure you remember to use the chain rule. Job done. I'll see you in the next video.